Hello, my name is Sharon. I am the Senior Manager for Maths and Science here at OpenWisdom Education. And today we'll be going through this question from the 2-unit HSC from this year, 2020. And this question is relevant to the topic of statistical analysis and more specifically the dot point of continuous random variables. So here's the question. Feel free to take a photo or pause this video to write this question down on a blank piece of paper, and then we'll get started. So let's just quickly go through this question and the important parts that we should get out. So this is a continuous random variable x, and it's given us a probability density function. And we can see that this PDF or probability density function is valid for the values of x going from 0 to k, and all other values of x give us a PDF value of 0. So the first part of this question asks us to find the value of k. Now, this question utilizes the fact that the area underneath all PDFs is equal to 1. Now, remember, the area underneath a curve is essentially just its definite integral. So if we look at this question here, we have sine x is valid as a valid PDF, for values of x from 0 to k. So that means that the integral from 0 to k of sine x should be equal to 1, because this is a property of all valid PDFs. And now it's just a matter of solving this integral and then finding what k is. So the integral of sine x, I'm sure you guys remember, is minus cos x. And because this is a definite integral, we need to make sure we have our square brackets going from 0 to k as our bounds. Now for definite integrals, remember we always substitute the top number first, and then we substitute the bottom number. So substituting that, we have minus cos k minus cos 0. Now remember, we are taking away this negative value, hence why I have drawn brackets around this cos value, and that is equal to 1. Now, just simplifying this down, we have minus cos k plus cos 0 equals to 1, because minus minus becomes plus. And then cos 0 is just 1, so minus cos k plus 1 equals to 1, which means that cos k is 0. Now solving for this, we have k is equal to pi on 2. So this is our first angle in the first quadrant. But remember, for the cos graph, if we just quickly draw that, if this is pi on 2, then every pi we reach 0 again. So I'm just going to write one more value, and I will explain why I'm only writing one more value. And to be honest, we don't actually really need this 3 pi on 2, because if we can see, PDFs must be positive, right? And so if we have a sine x as our PDF, and remember sine x looks something like this, because PDFs must be positive for their entire domain of x, my value of k has to be less than pi. If it's greater than pi, then I go into the negative region and I do not have a valid PDF, which means that the only value of k that works in this question would be pi on 2 and not 3 pi on 2, because 3 pi on 2 would be here, and here you can see we have a negative value for sine. So because PDFs must be positive for the given values of x, k must be pi on 2. So that's part A of the question. Now part B asks us to find the probability that x is less than or equal to 1, and they want us to give our answer correct to 4 decimal places. So to remember, to find the probability this is essentially just the integral of the PDF. But because this is the probability of x less than or equal to 1, this would translate to an integral from, so remember the smallest value that sin x is a valid PDF for is 0. So your integral would start from 0 and go to 1. Because this is x is less than or equal to 1. So it's values of 1 or, it is the value of 1 or values less than 1. And we can't go past 0 because that is the smallest value this PDF is valid for. So integrating this is now very similar to question A. So again, the integral of sin x is minus cos x. And then we substitute the top bound first. And then you can type this in your calculator, but the very important thing that you need to note is that cos 1, you must make sure that your calculator is in radians, because this, if you have a calculator in degrees and you type this in, you will get the incorrect answer. So when you type this in your calculator, making sure that the mode is set to radians, you should get 0.4597 to 4 decimal places, which the question asks us to do.